Welcome back to the course Mechanics of Solids. So, in the last lecture we were just discussing about the free body diagram of this kind of frame structure, okay? And we have seen that we have 4 members AB, BC, DE and BF. So, this was the free body diagram of the whole frame, okay, by separating out from the supports. So, at A we had hinge support, at C we had roller support, and this was the free body diagram of the whole frame. Now, after doing this, we are taking out each individual member from the frame and we are drawing the free body diagram of each individual member. Okay. So, in the last lecture we have drawn the free body diagram of AB like this, okay, and free body diagram of DE was like that. Okay. Now, we can continue with the free body diagram of say BC. So, this is a BC. Okay. So, at C we have already force Cx. Okay. Now, this was point E. Now, already in the last lecture we have seen we had chosen the direction of Ex from left to right. So, therefore, to satisfy the equilibrium condition, here we should have the direction of Ex like this. This is the only thing you need to remember, as I told you in the last lecture also. But still you may ask me why I have chosen Ex here from left to right and here from right to left. I do not have any answer, because I do not know actually the direction of Ex. You may choose Ex here from right to left, here from left to right, that is up to your choice. Okay. But you should be consistent with the direction when you are showing the common point. Okay. Fine. Here we have shown Uy in the vertical upward direction. So, here it will be downward direction. Okay. That is the only thing we need to take care, as I told you several times. Now, coming to Bx. Okay. So, before going for Bx or By here, we need to show the free body diagram of joint B, because joint B is a common point. Joint B is a common point for both the members, member AB and BC. So, let us draw the free body diagram of joint B only. So, that will be, that is nothing but your pin, okay, at point B. So, already you have shown Bx in this direction. So, it will be having Bx in this direction. Okay. So, here there is another thing you need to write. So, that is your WBC, that is the weight. Okay. Anyway, so for pin B, this was the direction, this was the force Bx, because Bx we had shown in this direction. So, Bx will be in this direction. Similarly, along upward direction you will be having By, we have shown in the downward direction. So, it will be By, okay, in the vertical upward direction. Now, from this, if we show the forces say Bx prime and By prime, okay, they need not to be necessarily same. Okay. So, I can show By is downward. So, here By will be, By prime will be upward, Bx prime from right to left. So, here it will be left to right, okay. And we have, okay, we have force R plus WBF. Okay. So, this is the free body diagram of the pin. Now, if I want to draw the free body diagram of the member BF. So, how to look like? So, this is a BF. So, at F already we have seen we R plus WBF is acting. R is the force already applied, externally applied force, and WBF is the weight of the member BF. So, equal and opposite force will be acting here. So, this will be R plus WBF. Okay. So, that is acting at point B. So, this point is nothing but this pin point. So, you see this is from this R plus WBF is acting in the upward direction. So, here it was in the downward direction. So, everything is perfect. So, this is the free body diagram of each and individual member of the frame. Now, you can analyze, you can take any member and you can analyze the system. That what are the analyze means you need to find out the magnitude of the forces. So, all the forces can be obtained by exploiting the equations of equilibrium, okay, if the structure is determinate. Now, what is determinate? I do not know. So, we need to discuss that thing in the next coming hours, right. So, this is basically showing you that how we can separate out each and individual component of a particular system and draw the free body diagram. So, this is without, now you will appreciate really that without drawing the free body diagram of each and individual component, it is very difficult to analyze the whole system, right. So, that is why the free body diagram is really emphasized, okay, in the problem of mechanics of solid. So, without drawing free body diagram, do not proceed at all for any kind of problem. So, that is the earnest request as well as the advice. Okay. So, now let us talk about determinacy, because that word just now came out from the discussion. Now, what is determinate structure and indeterminate structure? So, static indeterminacy. Suppose I have a beam, okay, which is having hinge support at this end and roller support at this end. Weight of the beam W is acting here. This is a point A, this is B. Another force, some externally applied concentrated force F1 is acting like this and F2 is acting like that. This is the point of application, okay, and this is your, this is in XY plane, okay. Now, what is your first job? As we have committed, the first job is to draw the free body diagram. Okay, so let us draw the free body diagram of this beam. This is the force F1, W, F2, and if I want to draw the free body diagram, so we have to replace all the supports, right. So, if I want to replace support A, then basically I should have two forces AY and AX. Okay. Similarly, this must be replaced with one vertical reaction BY. Okay. Agreed. So, this is your point B. Now, what are the unknowns? Could you please tell me what are the unknowns? This is known F1, because the structure in the actual problem, these are the externally applied forces, So, you should know, otherwise how will design? If you do not know what are the forces are coming on the structure, how will design the structure, right. So, the externally applied force must be known to you. So, F1 is known to you, similarly F2 is known to you, and if you know the dimensions of the beam and material of the beam, then W is known to you. So, they are not unknown, they are externally applied forces and you are quite familiar to these forces, okay. These are known to you. Now, what are the unknowns? Unknowns are the support reactions, you do not know those, right. I mean, how much support reactions will be getting developed for the application of these forces, how do you know that? You do not know. Those things you need to analyze, and if I say the beam is under equilibrium condition, and by exploiting the equations of equilibrium, you can find out those reactions. Now, what are the unknowns? Ax is unknown, Ay is unknown because they are not known to you, support reactions, and By is unknown. Rest of the things are known to you, F1, F2, W all are known to you except Ax, Ay and By. These are completely unknown to you. Now, if you recall your discussion on the equations of equilibrium, right, what was the equations of equilibrium? That is, resultant of force must be 0, resultant of moment must be 0. Now, if you think the structure in xy plane, if you think the structure in xy plane, then basically this structure will be the planar structure. Now, the force, all the forces are acting in xy plane, okay, there is no z direction force. So, how many equations of equilibrium available with you? You had 6 equations of equilibrium, right. Summation of f x equal to 0, summation of f y equal to 0, summation of f z equal to 0, similarly summation of m x equal to 0, summation of m y equal to 0, summation of m z equal to 0. 3 force equation, 3 moment equations. If you consider x, y, z, I mean that is the 3-dimensional state of I mean say force condition, right. But here your force and everything in xy plane. So, how many equations are available with you? 3, that is summation of f x equal to 0, summation of f y equal to 0 and summation of m z equal to 0. Moment with respect to z axis, z axis is normal to the board, okay. Z axis is normal to the board. So, summation of f x means summation of all the forces in x direction must be 0, that is the first equation of equilibrium. Then summation of f y equal to 0, that means summation of all the forces in y direction must be 0, and summation of moment with respect to z axis, because the forces are acting in x y plane. So, you will be getting the moment with respect to z axis if you see, right. So, if the forces in this plane, so basically you will be getting the moment with respect to z axis which is normal to the board, okay. So, you have 3 equations of equilibrium available with you to solve this problem, am I right? Solve this problem means, now if you exploit summation of f x equal to 0, so basically you take a x, you take x component of f 1, you take x component of f 2, b y will not be having any x component, and similarly w will not be having any x component, a y will not be having any x component. So, in that fashion you will be getting one equation. Similarly, if you consider summation of f y equal to 0, then a x will not be having any component into y direction. So, a y will be coming into the picture, y component of f 1 will be coming into the picture, w will be coming into the picture, y component of f 2 will be coming into the picture, and finally b y. So, that will form an equation, okay. And similarly, if you consider m z, summation of m z equal to 0, any point you consider, any point in the beam you consider, suppose you consider point A, that means you are considering moments with respect to z axis at point A. So, that F1 will be giving some moment, because if you know the point of application of this, so you know the distance, and from there you can find out the moment. Similarly, W will be giving you the moment, F2 will be contributing in the moment, By will be contributing in the moment, Ax and Ay will not be contributing, because you are choosing a point to calculate the moment. So, in that fashion basically you will be getting 3 equations, am I right? You will be getting 3 equations. How many unknowns are there? 3 unknowns. So, mathematically you can say that you can solve it. You can solve, or you can find out all the unknowns Ax, Ay and By by solving these 3 simultaneous equations. So, this kind of structure is known as externally determinate. Determinate structure means you can solve the structure, that means you can solve for the unknowns by using your available equations of equilibrium. Try to understand the definition. Determinate structure is that structure, okay, for which the unknowns can be obtained by using the available equations of equilibrium. That is your definition of the determinate structure. If it is not, if you cannot find out, then the structure will be automatically indeterminate structure. So, let us see the indeterminate structure. Okay. Now, in the same problem, what I am doing, instead of roller support, I am making this support is also hinge support. Okay. What I am doing, instead of making this roller, I am putting one hinge support. So, I have 2 hinge supports, one is at A, another one is at B. So, therefore, if I want to draw the free body diagram, so By will be having one more reactions, say B1 will be having, B point will be having one more reaction, that is Bx. Now, this Bx is known to you or not? It is not known to you, it is unknown again, because the support reaction C is unknown. So, how many unknowns are there now? You are 4 unknowns, Ax, Ay, Bx, By. There are 4 unknowns. How many equations you have to solve this? Only 3 equations. Those equations will not be getting changed, right, if you change the support condition, because you are dealing with xy plane. So, these 3 equations are available with you, but you have got one more extra unknown. So, 4 unknowns, 3 equations. Can you solve it? No, you cannot solve it. So, this structure is known as statically indeterminate. To solve this kind of structure, we need to impose some condition. Okay? So, those things will be coming later on when we will be discussing about the next chapter. So, at this moment, whatever problems we will be taking in this chapter, basically we will be taking the problem related to determinate structure. Indeterminate structure can be solved, but you have to do some extra exercise to solve it. So, is it clear to you? So, what is determinate and indeterminate? It is very important. So, whenever you are getting some problem, immediately you draw the free body diagram and then you check whether it is determinate or indeterminate. If it is determinate, fine, you can solve it by using your equations of equilibrium alone. If it is not determinate, if it is indeterminate, then you have to include some more conditions. Apart from your equations of equilibrium, you have to impose some extra condition. Okay. So, now we are coming to a new topic, that is plane stress. Okay. So, you might have seen this kind of structure several times in your life, whenever you travel by some railway bridge which is having, you might have seen this kind of structure. So, you might have seen this kind of structure on some railway bridge or some highway bridge, right, this kind of structure made of steel. Okay. So, this is known as plain truss. The classical example of this plain truss is your Howrah Bridge, okay, as I told you. Classical example of plain truss is your Howrah Bridge. Even if your Eiffel Tower is an example of truss, but that is not the plain truss. So, we are not going to discuss about that thing, that is your space truss. So, that is not included in your syllabus. So, but that is also a truss member. Okay. Those members are truss members. Okay. Now, there are few things you need to know for the plain truss. What is truss? A truss consisting of a coplanar system of members. A truss consisting of a coplanar system of members. So, when I am talking plain truss, basically the truss is made in one plane. Okay. So, if you look at this truss and if I say this is my xy coordinate system. So, basically in xy plane the truss is having the members. So, all the members are connected in such a way that it is expanding in xy plane. Okay. So, there is no z direction component or z direction members. So, if you have the z direction members, then basically that will be known as space truss, as I told you. Okay. So, that is not included in your syllabus. Okay. Then the external loads must be applied at the joints. Okay. So, what does it mean? So, if you have the truss like this, suppose this is one truss, this is the support, simple support. So, this hinge and roller supports together is known as simply supported structure or the simple supports. Okay. So, these supports are known as in mechanics, subsequently I will be using this term simply supported structure, simply supported structure. So, simply supported means it is supported on hinge and roller support or something like that. Okay, fine. So, this is one truss. Okay. These are all joints. Okay. These are all joints. Now, the next statement is said the external loads must be applied at the joints. So, whatever external forces are coming, any external force, that they will be acting, that is the assumption, and that is a fair enough or fair good assumption. Okay. All external forces, say if I apply some external force, if I apply some external force, if I apply some external force, all external forces are applied, okay, at the joints. Now, how these joints will look like? So, let us look at this problem, look at this figure. So, this is one typical joint. Joint does not mean that it will be a simple pin joint or something like that. It may have several members emerging from the joint. So, this is one member, this is another member, this is a truss structure, another member, this is another member. Okay. So, 4 members are coming out, like these joints, if you consider 3 members are coming out, 1, 2 and 3. How many members are there in this truss? 1, 2, 3, 4, 5. There are 5 members. They are connected by joints. Okay. The joints may be welded, joints may be riveted like this, or joints may be bolted, whatever. Okay. They are joints. If you look at this figure, so these are all joints. This is joint, this is one joint, something like that. Okay. So, the next assumption is, that is the second assumption, that is the external loads must be applied at the joints. So, we are not going to consider any force which are applied in between the member, that is our assumption. Okay. Or rather you should say that is our idealization of the problem. We need to idealize the system. Okay. Well, so I will stop here today. So, in the next class we will continue with this truss and how to analyze this truss we will see, and we will learn few methods by which you can solve the truss. Solve means these member forces, basically what is the idea. If you want to design a truss, okay, you want to design a truss. Now, first thing is that you should know what are the support reactions, that you will be getting, as I told you, by using your equations of equilibrium. Then once you know the support reactions, under the application of the external forces, what are the different member forces? Member forces means there are 5 members in the truss. So, those 5 members, how much forces they are carrying. So, based on those forces, basically you can design the member, that is the idea. So, you need to analyze the truss to get the member forces. Well, so I will stop here today. So, in the next class we will continue with the truss analysis. Thank you very much.